Hello, in this video we are still working through section 9.1 on parametric equations, talking about finding parameterizations for curves. And if you recall from the lecture, parameterizations for a given curve are not unique unless you put an extreme number of restrictions on the type of parameterization. You are never going to have only one unique answer for a parameterization for a given curve. So in this example, example 5, we are asked to find 3 different sets of parametric equations for the curve y equals the square root of x. So the only thing that we need to do here is we need to make sure that our parameterizations give the entire curve for y equaling the square root of x. So it's good to think about what our domain would be, and that's that x must be bigger than or equal to 0. So whatever we choose for our parameterization, we have to make sure that the x values are only going to be all positive values, so we can maybe do that based on our parameter interval or based on whatever function we choose for x. And then we also need to pay attention to the range. Since this is a positive square root function, it means that y is also going to be bigger than or equal to 0. So we need to pay attention to both of those things with our parameterization. The first option, the easiest one, is to simply let x be t. T will need to be bigger than or equal to 0 because of our domain, and then y will be the corresponding function of t. Another option is if we solve this for x so that we get x is equal to y squared. Then we would let y equal t. Now, if y is equal to t, we need to pay attention to the range. Again, the range is y bigger than or equal to 0, so that's still going to be t being bigger than or equal to 0, and x will then be t squared. If we want to check to make sure this matches up with our domain, since t is bigger than or equal to 0, it means t squared will be bigger than or equal to 0, which does match up with that. So both of these will work. From here, if we wanted to, we could get a little bit more interesting. Let's say we didn't just want x be equal to t, we wanted x to be, t plus 1. Okay, well, if x needs to be bigger than or equal to 0, that means t plus 1 must be bigger than or equal to 0, which means that t must be bigger than or equal to t negative 1. So that is then our interval on t, and y would be the corresponding function of x, so the square root of t minus 1. And again, if we wanted to check, t minus 1 is always going to be bigger than or equal to 0 because t is greater than or equal to negative 1, so it works out with our domain. And the square root function will only give us positive values, so it works out with our range as well. So these are 3 different options for parametric equations here. There are an infinite number of correct parameterizations that you could choose here, but like I said, you do need to be careful to make sure that your domains and ranges are the same. You can generally end up doing that by making sure that your parameter interval satisfies those requirements. Occasionally you have to be a little careful there. So what I mean by that, let's do this. An example that doesn't work would be if for some reason you said, well, let's be crazy and let x be equal to e to the t, and then y should be equal to the square root of e to the t. But the issue there is the exponential function is never equal to 0. So this means that x would be strictly greater than 0, which would also then mean that y is strictly greater than 0, and this is true for any values of t. It wouldn't matter what your interval on t was. Even if t was unrestricted between negative infinity and infinity, you would still never get x being equal to 0. So this parameterization doesn't work because it doesn't pick up the point 0, 0 on the curve. So when you find a parameterization, you need to make sure that you get all of the curve that is being described, but nothing more than that, okay? Even with the restrictions on the range and the domain, you are still not going to have a unique answer. So with your parameterizations, pay attention to the domain and the range. Other than that, you have a lot of choices that will work. And this does wrap up our solution for example 5.